Hello everyone, I am Giray Altuğ Korkmaz. Today, I'm gonna try to explain our data structure with Java assignment. And by the way, today is Eid al-Fitr and happy Eid al-Fitr to everyone. And let's start with the explaining the general profile of the our codes. Demonstrates the implementation and use of the linked list data structure in Java. This is our comprehensive linked list implementation consisting mainly of the following components. And we have different components. And first of all, we have L-list. L-list, a standard one-way linked list implementation, and we have a L-list refined, a refined linked list implementation, like adding direct access to the last node, and we have list interface too, as you see in code. After showing this code, I'm gonna explain the code, and this is similar to our fifth assignment, but I have to rename. This is list interface to.java, and the interface defined for the list data structure, and we have finally list client assignment, the client code that tests the linked list implementation. Let's talk about the general function and what's the purpose of the codes. This implementation is a comprehensive example of the single linked list data structures that is often taught in data structure courses. Linked lists are dynamic data structures that store data in nodes, where each node points to the next node. Linked lists, unlike arrays, have no fixed size and can grow shrink dynamically. This structure is particularly advantageous in applications and where additions and deletions are frequent. For example, adding elements to a list from the top or middle is more efficient than an array because it's not necessary to shift all elements. And let's start the examining the code with list.java, and this class represents a generic singly linked list implementation in Java, and it follows the list interface too. After I will explaining this code, I will explaining the list interface to.java, and it follows the list interface to interface, meaning it must implement certain methods defined by that interface. And first of all, we have also public class methods, and we have two variables and first node and number of entries. First node stores a reference to the first node of the linked list, and number of entries keeps track of the number of elements in the list. And we have a constructor. This constructor initializes the linked list by calling initialize data files, which sets up the list's initial state. And we have a clear method. We have also initialized data files, and we assign the first node equals to null, and we assign number of entries equals to 0, first node equals to null shows us the list starts empty with no nodes, and number of entries equals to 0. The list initially has 0 elements, as you see in the code. And adding elements method, there are two versions of the add methods. And first of all, public void add t new entry and new node equals to new node in the new entry in the parentheses. A new code is created with the given data, and we have if else statement. If the list is empty, the new code becomes the first node. Otherwise, the else condition, the last node is found and the new node is attached to it. And the size of the list, number of entries list, by 1. And our second adding methods, we have also add method, but it's different from each other. And in here, public void add in new position t new entry. We have also if statement. This if statement ensures that the position is valid, and the other part, node new node equals to new node new entry in the parentheses. And if adding at the beginning, the new node becomes first node. And if adding somewhere in the middle or at the end, it is inserted between node before and node after. And we have throw new index out of bounds exception. If the position is out of range, an error is thrown. And we have removing method, and this method removes an element from a specific position. And public t, yes, remove int given position, t result equals to null. Result stores the removed elements data, and we have also if statement. If given position greater or equals to 1, and given position smaller or equals to number of entries, ensures the position is valid. And sorry, if given position equals 1, the first node is removed and the second node becomes the new first. Sorry. Yes. Sorry. If given position, yes, if given position equals to or assigned or not 1, and the first node is removed and the second node becomes the new first node, and we have else and node node before, node to remove, and node after, and finds the node before the one to be removed, updates the links so that the node is skipped, and we have number of entries, and we have the return results. The list size is decreased by 1, and the removed elements data is returned. And we have a replace method, and this method replaces an element at a specific position. And we have also a if statement, and we have also return our values. And our purpose of this code interval, finds the target node and replaces its data and returns the old data before replacement. And we have also contains method. The contains method iterates through the list to find a matching element, returns true if found, otherwise false. And get length method, and it returns us to length of the list. And we have is empty method, checking the list is whether or not, and if the list is empty, it returns true, and otherwise it returns false. And both two condition, it returns results us. And we have also to array method. A new array is created and to store all elements. Sorry. And we have index. Our index is equal to 0, and copies all elements from the linked list into the array. And we have get node add method. This get node add method traverses the list to find the node at given position. And we have node inner class. We have two variables. Each node stores a value and a reference to the next node. And we have a node, but it requires a t data parameters, and creates a new node with a value but no next node. And we have another node. This node interval creates a node and links it to another node, and it's constructor. And we have get data, set data, and get next node, and finally set next node method. It returns us a data, and it equals to this dot data equals to data, and return next. And this it set next node method, setting the next node with equation, which is this dot next equals to next. And sorry. And let's take a look with list interface 2.java. And we have a public interface, list interface 2. This line defines a interface, and this interface takes a generic type, as you see between the smaller and bigger symbol of the T. And this allows the interface to be used for different data types. And void add, and this method is defined to add a new element to the list. It takes the element to be added new entry, as you see. And this method returns no value because we have void. And we have another add method. This method is defined to add a new element to the list at a specific position. It's the difference between our first add method, and it takes as a parameters the position to add the new elements and the elements to be added. This method returns to removed element. Sorry. And we have a void in this case we have no returns, and these elements also no returns. And we have remove method. This method is defined to remove an element at a given position from a list. It takes a position, which name is given position of the elements to be removed as a parameter. This method returns the removed element. And we have clear method. This method is defined to clear the list completely and remove all elements. In the other hand, this method returns no value, void, because we have replace method. This method is defined to replace an element at a given position in the list with a new element. It takes as parameters the position of the elements to be replaced, which name is given position, and the new element, new entry. This method returns the replaced old elements, and we have getEntry method. Our getEntry method is defined to retrieve an element at a specific position in the list. It takes the position of the element to be fetched as a parameter. This method returns the fetched elements, and we have toArray method. This method is defined to convert a list to an array. This method returns an array containing all the elements in the list. And we have Boolean, which names contains. Contains defined to check if a particular element exists in the list. It takes the elementor and entry and to be checked as a parameter. This method returns true if the element is in the list, false otherwise. We have getLength method. This method is defined to get the length, number of elements, and another say of the list. This method returns the number of the elements of the list. We have also isEmpty method. This isEmpty method is defined to check if the list is empty. This method returns true if the list is empty, and the otherwise it returns false. And we have list client assignment. List client assignment is our test area. We can have a chance to test list interface 2 methods, and we defined a main method, which is the starting point of Java applications, and this method only calls the method names test example 2. So the actual test of the program will be performed in this method. We have also public static void display list. As you remember in the previous assignment, we have also used this display list, and this is our helper method. It helps us to display the contents of the list on the screen, and we have a yes, and number of entries, yes, and we have test example and public static void test example 2, and we have a list interface 2 string. And by the way, in this area can be changed with integer or string or whatever you want within the data types, and this means that any list interface 2 implementation can be passed to the method, and the generic type is string, so this method will display string lists. And we have some car brands, and in this list client assignment, and I want to show the first add method as I wrote the area, and we have some car brands. I use these brands for the showing the adding example, and after that displaying the list. Toyota is entry 1, Ford is entry 2, Nissan is entry 3, Tesla is entry 4, and Audi is entry 5. And displaying the list, and let's take a look with other add method, second add method, and we have we use this method that we want to add specifically position in our lists, and as you see in the example, and I want to add for Bentley for position 2. It's added with the 2 as you see. In our first example, our second element is Ford, but the second adding method, our second element is Bentley, and first, and explaining the other add methods. Let's explaining the remove methods. Remove methods remove elements that is entering in the parameter. In our example, I want to add one for removing, and let's run the code. And remove, yes, and Toyota is removed by the list, and our Bentley is in the entry 1, and we have a remove method, and remove methods as I explaining our list.java remove all elements, and 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 after the clearing the list, I want to add some car brands, which is different from our previous ones, and it's printing our test area, and our replace method replace our given position instead of our parameter is which name we want to add, and as you see in the first part was Aston Martin, but our replacing method it changed by the Chevrolet, and we have get entry method, and we have an error, and sorry, and I will fix the code, and yes, and we have and invalid index. Yes, the code is clearly running. Sorry for the sorry for the error. We have 4 indexes, but I give the entry number of 5 because of the error, and uh, it gives the given position as, and we have also and contains and is empty elements. In this case, checks whether Toyota is in the list or not. And as you see, Toyota is not in our last list. It's because of it returns Toyota is not in the list, and and we have finally is empty method and also checks whether our list is empty or not, and we have some elements in our list. It's because of our list is not empty. And explaining the code part, and we have I have to explain, sorry, I have to explain difference between list and list refined, and these two classes provide essentially the same functionality, uh, but list refined offers a more efficient implementation. Here are the main differences between them. And the a list class has to scan the list from start to finish each time to add elements to the end of the list, ON complexity. This is done to find the last element of the list by calling the getNodeAdd method. And the list refined class keeps the last node of the last node as a reference. In this way, there is no need to scan the list from beginning to end to add elements uh, to the end of the list, and the operation takes O1 complexity. And I want to show the last node. Yes, last node, and this optimization provides performance improvement, especially in large lists. Additionally, the isEmpty method in the list refined class has been simplified and some checks have been improved. These two classes are an example of optimization, often shown in data structures courses, and demonstrate how small changes in linked list implementation can affect performance. Let's take a look with and our time complexities, and we have a list. It's difficult to write without having mouse. A list, sorry for that. And we have a list, and we have a list, and a list was our on previous example, and a list is in our courses. And let's take a look with our time complexities, 3 classes, and we have add method. And in our first add method, our list time complexities is ON, and our list time complexities is on also. And our list time complexity is O1. And in our second add method, and also on and also on, and we have on in here, and we have remove method, remove, and we have also on, and we have also on, and we have also on in our remove method. In clear method, and we have on, we have o1, and we have o1 also. In our replace method, and it's o1, it's o1, on, and it's on. Get entry method, and we have o1, we have on, and we have on also. And I want to clear all the page because it's not filled in our page. And let's take an eraser. Sorry. Let's take another page. Sorry. And we have two array method. And our list time complexity is on. And our list time complexity is on. And our real list time complexity is also on. And contains method contains, and we have on in our list time complexity is on, and we have also on in list, and we have also on is real list, and we have get length method, get l, and we have O1 for both of them. We have is empty method. We have also O1 for both of them. And we have get node at method. Uh, we don't have get node at method in our A list because we don't use in our A list. And ON is our get node at time complexity, and ON also is our real list time complexity. And oh, sorry, I want to name this get node at. Sorry, get node. And we have initialized data files. And we don't have also initialized data files for our A list, and we have O1 and we have also O1 in our L list and rel list. It's our time complexities by listing the methods. Thank you for watching us. By the way, sorry for the error and sorry for the writings. It's very weird. Thank you for watching us. Thank you for watching me. Sorry. Thank you for watching me. See you in the next assignment. Thank you.